So we've got two forces. We know the angle between them. We don't know what angle they're acting at. I've got to find the magnitude of the resultant of these forces and the angle between the resultant and the 10 Newton force. Okay, for this I'm going to use a triangle of forces. So for part 1, I'm going to start off by drawing the 10 Newton force. Try to draw it exactly the same angle as I had up there, and that's 10 newtons. And then I've got to work out the resultant, I've got to stick the 6 Newton arrow onto the end of this one. And so I'm going to try and make it parallel, so that's going to go something like that. And that's 6 newtons. And what I need to do, I'll do it in green, I need to find out that bit there. That's the resultant, I won't call it R. That's the resultant, that's what I need to find. Call it X. And the angle I'm told about is, I know that we had 110 degrees here, so if I slide this one 6 Newton down, that's 110 degrees, and so therefore this one is 70 degrees. And now it's dead easy to find out what I've got to get, because it's going to be the cosine rule. So the magnitude, so I've got x squared equals 6 squared plus 10 squared minus 2 times 6 times 10 times by cos of 70. Make sure my calculator set properly. Write down x squared, which equals 94.95758. It's worthwhile doing that because you can see it's not going to be 94. But if you're writing the x squared down, it just reminds you that you've got to square root it to get 9.744618. And we've also got to work out the angle to the 10 Newton force. So I've got to work out this angle here. So question mark. And that's going to be, well, now I have a known pair. I know x and I know this, so I can work out the angle. So sine of the angle over 6 equals sine of the angle there, which is 70, over my length with it, which is 9.744618. And if I times everything through by 6, that gives me sine of question mark equals 0.57859176. So the angle equals 35.3515 degrees. Obviously, you round them to 3 significant figures. So that's that bit. The two forces act in the same vertical plane. Particle P has a weight of 20 newtons, so I'll put that on my diagram here. That's 20 newtons. And rests in equilibrium on the surface. Given that the surface is smooth, therefore there can be no horizontal component to this force, and that means that this bit R always goes straight up, but also the resultant of these two forces, I'll do it like that, but that's meant to be actually going straight up as well. And that is, we just worked out, 9.744. So that's 9.744. And now I can resolve upwards. So for part 2, I can resolve upwards. And that means that R plus 9.744 plus the rest of it equals 20. So R equals 10.255382. And the last part, part 3, I need to find the angle between the surface and the 10 Newton force. So I need to find this angle. I'll do it actually in red. I need to find this angle here, but I know that this angle here, I've worked out that one already. That is 35.35. And that resultant has to be going straight up, and therefore this one here, obviously, angle equals 90 minus 35.3515, which equals 54.64844. Again, round everything to 3 significant figures, but that's question 4 done.